sorry, logistic regression is like one of your part of a regression techniques. Okay, like here exactly you have only the discrete values, right? When yesterday we compared the linear regression and the logistic regression, we came to know that in linear regression we have some values which are continuous in nature, right? And in logistic regression, what happens? You have the values which are like in the discrete, right? It could be true, false, it could be 0, 1, yes, no, success or failure, or anything like that, right? Okay, that are coming in the logistic reasoning part, logistic regression part. Okay, so we'll take a data from here, okay, and then we'll explore it, make a model with that. Fine. So yesterday I also said that there are a lot of things to be read in this linear and all this logistic and all. Right? I said yesterday we'll also go with all those methods and techniques and formulas and all those. Okay. So we'll go one by one. Okay. Fine. So in the logistic part, okay. First of all, we'll have to import the dependencies. Okay. So like these are the basic first five libraries, 4 5 libraries which you have to import it, right? And then we'll start up with this conference. Okay, fine. So we are going to go with the iris dataset, right? With the iris dataset. Okay. So how we can go with that, right? How we can go? So even if you don't have the iris dataset, what you do is you write or you load the dataset from this SNS, right? It gives a lot of dataset free of cost for like practicing, right? So we'll load a dataset from this SNS, right? And then we'll go with the head of that. And this is your head, like you have sepal length, sepal width, petal width, and species. And we, as we saw yesterday, I think yesterday or day before yesterday. Okay. So how many columns you are having? So you are having sepal length, sepal width, petal width, and species. It's nice. Okay. Now, how many species are there with the category itself? So, you have Versicolor 50, Virginica 50, and Setosa 52. Right. Cool. So, if we start up doing some problems here, like, so what happens when you go for training a model, like, or when you go in a machine learning process, what are the first steps you would have to follow? Okay, like if we say that a machine learning process, right? What does this includes? What are the process includes in this machine learning? Right? So the very first thing is you have to define your objective. Okay, you have to define your objective. The next is you have to go for your, or you can say you have to gather your data. Third is the data exploration part. Then you go with building a model, and then you go with the model evaluation, where you check how much accuracy your model is bringing up. Okay, you actually test your data there, and then you finally do the prediction. So these are the steps which includes in a machine learning process. Okay, whenever you start modeling any criteria, when you start creating any model, first you have to define your objective. And as I said, whenever you apply for any post of like this, like anything, you will be asked that this is your data, go and do a EDA process, and then make a machine learning model with it, with any one of the using any one of the algorithm, right? And best is always your supervised. Okay, so always try to use supervised. Fine. So yesterday we did up to the which one? Email. Okay. Confusion matrix. What is? Okay. Fine. So here we'll come to understand with some of the topics like for the confusion matrix and accuracy score, right? The metrics and all those things. Okay. Now, see, now whenever you start working in machine learning, these are the four basic dependencies what you have to import. This is matplotlib, pandas, numpy, and seaborn. Okay. Apart from this, when you work in the ML, so you have to import some packages more, some functions and some classes even, right? So what are those things? So that is like import more packages, functions, and the classes that you have to do. Okay. So these are actually the common types when you go with the SL supervised. Okay. So those are actually that you have to write from sklearn dot linear model import logistic regression. Okay. And from sklearn dot metrics import classification report. The confusion matrix and also the accuracy score. Okay. So this is also to be imported from the right. Now how we get actually the data, right? How we get the data just like in one glance. So if you want to see this type of regression, right? So let's say this is your X and this is a range of 10 numbers, and then I'll reshape this in -1 to 1. Okay, and let's say this is your Y. Which is, let's take it as an array. A 1 2 3 4 5 1 2 3 4 5 6. Okay, fine. So like that we have built, right? Okay, fine. So this is your X and this is your Y. Okay. Now, see, in supervised learning, as I say, the most important thing whenever you go is the classification. Okay, so if like someone asks you what is classification and all those, so you could say that classification is a technique used in machine learning algorithm which defines that model can capture relationship among their data, right? So it's an area of SL, which is supervised machine learning, SML you can say on, okay, that tries to predict which class or which category or which entity someone belongs to. Okay, that is the, you can say, the basic definition of this. So here you have some independent variables and some dependent variables. We talked for that yesterday, right? The binary, the multi-class, and all those. Okay. Now, logistic regression is a fundamental classification technique, and as I say, you will be having the values here as a discrete one, the 0 and the 1. Okay. Fine. So you will need some mathematics here, like for the sigmoid function, natural logarithmic functions, and all those things, right? So I think that is clear to you. If it is not clear, I have uploaded the things, the mathematic parts in the drive. You can go there and learn from the mathematics section there, right? So that you can do, okay? The mathematic parts and all those, fine. So like you always try to form a problem first. The first step for you is to form a problem, right? Okay, so you will be forming any problem and then you will be working on it. Okay, so as much we'll start up with. Okay, so like whatever you see here is a classification report that is actually given as a classification performance. Okay, so there are actually four type of performance which could generate in a classification type. So if we say that classification performance, so what I'm saying that binary classification has mostly four possible types. Okay. Now, what are those four possible types? Right. So the first one is true negatives. And what is this true negatives? These are correctly okay. Huh. So these are correctly predicted negatives. Okay. That is also, you can call it as the zeros. Okay. Then we have true positives. Now, actually, when we draw a confusion matrix, we get these things only, right? So true positives are correctly predicted positive value. Okay, that is your ones. Similarly, you have false negatives, right? And those are incorrectly predicted negatives. Because as I said that you will be only having the values at the zeros and the ones. Okay. So let's say this is 0. Similarly, the last is the true negatives. Sorry, two have been done. So let's take it false positives. So false positives are incorrectly predicted positives. That is once. Okay. So you usually evaluate the performance of your classifier by comparing the actual and the predicted outcomes. Okay, that is incorrect and correct predictions. Okay. So the most straightforward indicator of this classification, right? This classification accuracy is to the when you go for this one, this accuracy score. So this is the ratio of the number of correct predictions to the total number of predictions. Okay, so these are the terms which has to be kept in mind, right? So what is accuracy score? It's like one asks you what is accuracy score. So you can define that this is the it is the ratio, you can say ratio of number of correct predictions to the total number of predictions. Okay, right? Or you can call it as observations. So this is particularly your accuracy score. Understood? That is called as the accuracy score. So the positive predicted values, this positive predicted values is the ratio of the number of true positive to the number of true false positives. Okay. And the negative predicted values is like true negatives to the sum of the true and false negatives. Like that you make some things over, right? Okay. And okay, now there are various type of regressions like in the logistic also. You have single variate logistic regression. Like so, single variate logistic is most straightforward. Like you will be having only one dependent variable, like you have in the single linear regression. Simple, right? So one dependent variable, and then you can for the multivariate, it's like you have more than one input variables, right? So two kind of logistic are there, like single and one. Okay. So logistic regression determines the weights. Weight you can say weight is nothing but the you can say the value you want to give to your model. Sorry, not the model feature. The value you want to give to your feature, that is called as your weights. Okay, fine. Then like as I said yesterday that you have one regularization process, which is like a process of overfitting and underfitting. Like if you don't take the features exactly what you want, again some errors. Okay guys, as I said, weather problem, so Wi-Fi was turned off. Okay, till where you have seen, right? This problem is keep on all the classes. Till where you have seen, guys, right? You have seen these true negatives and all those. Yes, because I was on continuous and I just saw here that there is no one. So till where you have seen, right? Tell me the classification performance or where till where you have heard. What was the last topic you guys heard? Quickly. Yes, yes. What was the last topic I was discussing? What you heard?
Just now you started accuracy score, sir.
Accuracy score I started. Okay, fine. Thank you.
Yeah.
Okay, accuracy score. So I said that's the ratio of the number of correct predictions to number of total predictions put together. Okay, fine. Rest everything are there in the video. That is it. So as I said, there you have two kind of basically logistic regression are the two kinds. It is one is your single variate, okay, single variate LR logistic regression, and the next is multivariate logistic regression. Okay, so in the single variate itself, you have one particular data, and the multivariation you will be having two data over there, more than one data, right? So as I discussed yesterday in the regularization process, that you are having overfitting and underfitting. So overfitting is one of the most serious kinds of the problems you can say. Okay, so like it occurs when a model learns the training data too well. Okay, so when a model learns too well a data, right? So that is like overfitting process, because that is not exactly the kind you can give to a model, right? You cannot give every feature to a model. That will be a case of overfitting because it will not predict the values incorrectly. Okay, sometimes it may work, but not always. And also, if you don't give the sufficient required kind of the features to your data, that will be in a case of underfitting. Okay, so logistic regression, that you have understood, right? That is, if I go with a summary of all these, so there is two type, okay, and all are the packages what I have imported there, right? So we'll start. Okay, now like the package scikit-learn we are using, okay, scikit-learn. So this is also the most popular, you can say, tool for this machine learning. Okay, so here you first go with 3 4 kinds of data, right? You go with the pre-process of your data, you go reduce the dimensionality of the problems, you go with validating the models, you go with implementing the cluster analysis, and a lot of things are there. Okay, so we'll make something with the help of this logistic regression. Okay, so we'll start now. Okay, now let's say that we have imported the packages and all the things. Okay, fine. Now this x and y, bring this down. Okay, fine. So the array x, what you see here is required to be two-dimensional, right? So it should have one column for each point, and the number of rows should be equal to the number of observations, we can say, right? So to make x as a two-dimensional, I have made reshape to that, right? And that could be now a two-dimensional one. So if we just print on our x and our y, so let's just take x. So if we just print the x, so let's see as 0 to 9. Same for the y, will be an array. Nice. Accuracy score. Okay, everyone was on the accuracy score. Fine. So x and y, right? So x has two dimension, one column for a single input, and 10 rows, each corresponding to one observation. Okay, each corresponding to the each of the observation, right? So we'll make a quick model with this x and y. Okay, just a random one. So we'll create a model and we'll train this. Okay, fine. So once you have given the input and the output you prepared, you can create and then you can define your classification model, right? So you are going to represent it with an instance of logistic regression. So what you'll do is you'll say that this is your model name, okay, and you will pass this logistic regression, right? And there I'll be using solver, which is linear, and I'll discuss what are these things. Random state, and let it be 0. Okay, fine, cool. Solvers and okay, fine. So okay, what is this? So this statement particularly what I have written is this will create an instance of logistic regression and will bind it with the reference of the variable models, right? So what is this solver and random state? Okay, so in logistic regression, see, you will come to know with a lot of you can say parameters. Okay, you will come to see with a lot of parameters. So I'm writing all the parameters you will be getting in this. Okay, so the very first thing is you will get something called as penalty. Many a times, if you search on for the, if you browse for the websites or anywhere, if you study on these things also, if you come to go with the books also, wherever also you will find those things, right? So what is penalty? So it is a string. Okay, it is a string. By default, it's 12. So you can write as 12 by default. Okay, and what it does actually, it decides whether there is a regularization and which approach to use. Okay, okay. So if we say okay, it decides whether you can say there is a and which approach to use. Okay, so also like in place of 12 you get L1, you get elasticity net, and you get none. So all the three options are the rest of in place of L2. The options you have, L1, you have elasticity net, and you have none. Okay, these are the kinds you have. The penalty. Okay, similarly, okay, there is one called as C. Now you can say C is a positive floating point number. Always, whenever you will write, you will pass on the function, you will get C something else like that. Okay, so C is, you can say, is a positive floating point number, and mostly by default you will see something like this, 0.001. And it defines actually C. One second. Floating point number should be, no, this would not be. This would be 1.0. Yeah, 1.0. So it defines the relation. Okay, it defines basically the relationship or the relation you can say on. Okay, or relation of the relative strength of this regularized. Okay, so this is very important. There is one more, fit intercept. Okay, like, so that is not much of use. So whatever are for our use, we'll be focusing on that. Okay, like we'll be getting one as called, we have used random state. So let me tell you about that. Random state is basically an integer, as you can see I have written there, right? So this is basically an integer, or you can say an instance on numpy, right? So it defines what random number generator to use, right? What random number generator to use. What it does is actually, you can also write none, you can define. So it defines what pseudo random number generator to use, right? How many times training will go on. Okay, so if I 0, then it will go only for 1, and if you leave 3, so it will go on for 3 times, like that, right? So it defines random pseudo random number generator to use, right? And the next is like what we have used, like the DB solver and like solver, it is said. Okay, so this is also a string that decides what solver to use for fitting the model, like Newton CG, LBFGS, SAG or SAGA, or this liblinear, like that. Okay, so by default it is always liblinear. Even if you don't write liblinear, it will take a liblinear one. Okay, so this solver, where it is, yeah. Say for the solver, it is a string which is by default liblinear. Okay, and it defines what solver to use for fitting the model. And some of the examples is like Newton, CG, like that. Okay, so yeah, these are the things what are required and what I use, right? There are a lot of parameters. So liblinear solver does not work without regularization, right? So Newton, CG, SAG and SAGA and LBFGS and a lot of there are that suppose L1 regularization. So once your model is created, you need to fit them. But once you have passed on the logistic regression there, once it is created, you need to fit them or train it, right? So model fitting, if you say, again a term comes as like many times. So these are actually in the machine learning, you have to make a lot of notes basically. So I have given you everything. So model fitting, if like asked, so you can say it is a process CSS uh, of determining. So you can say it's a process of determining the coefficients particularly that corresponds to the best value of the cost function, right? So what you do is nothing but you'll just say model dot fit. What you have to fit? The x and the y. Okay, and x is small, I think. The x and the y, and you can see the class weight, the dual fit intercept scaling ratio, max iter, multi-class, n jobs, penalty by default it's 12 as I said. Okay, and random state solver and all these things. Okay, fine. So whatever the x and 10 1 1 1 4 zeros and 1 2 3 4 5 6 ones and reshape and okay, fine, cool. So now what this fit actually does, this once you have fit x and y, what happens here? So it takes x and y and possibly every observation related to the weights, right, regarding the coefficients you can see. Okay, so then it fits the model and returns the model instance itself, right? So what do you get there, right? So like what you have get is the string representation of the fitted model. Okay, now what you can do is you can say model dot classes. Okay, so you can quickly, like if you write this, you can quickly get the attributes of your model. For example, the model dot class, if I write like this, so this represents the array of distinct values that y takes. So this is 0 and 1, or you can say as like the common unique values, right? Similarly like that. Okay, now this 0 and 1 is nothing but a binary classification what you are getting there, right? So it says this is model is having these things, right? So you can quickly just write what is the intercept, what is the intercept of your model. This is what is the coefficient of your model. This is the coefficient. Okay, so you can see like there is one dimensional array and inside that a two-dimensional array, and you are getting the intercept and the coefficients. Like now it's time to like evaluate your model. Okay, Now, in the evaluation process, once your model is defined, you can check it the performance. You can check the performance of your model just by using it with your model name and then write predict the probability. Okay, and this returns the matrix of probabilities that the predicted you can say outcome or output is equals to 0 or 1. Okay, that would be the probabilities you would be getting x, and these are the outcomes, like the outcomes of the probabilities what you are getting the uh, as per your x. Okay, so like here each row, if you find for the each row, so this each row corresponds to a single observation, right? The first column is the probability of the predicted output being 0, that is 1 minus the probability of x, right? The second column is the probability of the outcome of the 1 as for the p of x, you can say the probability of x itself. So if you go and if you see your model dot predict on the x, if you predict the x values, so you can find it as 0 0 0 1 1 1 1 1. But if you see your y values, so that is 0 0 0 0 1. So if we predict the values, we are getting just one value less, right? We are having 4 zeros and 6 ones. After prediction we get 3 zeros and 7 ones, right? So you can see the difference in the prediction values. Okay, and now we'll have to make a graph actually with this. Okay, so if you plot this x and y, or if you just uh, go with the plotting by making a line and all those correct things and like that, so you can just plot it plt dot plot model dot predict and the y. Oh, so like you can see the graph, it's like an L graph over there, right? You are having the values of 0 0 0 0 1 and then 0 and here 1, right? That is not a good one. So you can go for a scatter plot. You can find the things like 0 1 and 1. This is most of the cases you will find one more dot here, but it's not here, like because we have very less data to explore on. Okay, so if you see your data would be like this, you will be having something in the range of only 0 and 1, right? So we'll go with it, don't worry, we'll predict things more. Okay, so if you find the score of a model, so score of x and multiply it by 100, so score is sorry, x comma y, score is 90%. That's nice. Okay, because only one value out of 10, only one value is there which is coming wrong, right? There's three zeros and this, so we are getting a 90% score on this data. So the lesser the value, better the result. Okay, so the more the data you'll make, you'll have to pass on a lot of things. Okay, okay, so you can get more information if you pass a confusion matrix. Okay, so confusion matrix, we'll go to it, what is confusion matrix and how it helps. Okay, so like if you want a good accuracy of a model, you can go with the confusion matrix. In this case, like binary, in the binary classification, confusion matrix shows a true negatives, a false negatives, a false positive, these things what I have discussed above, a true negatives, true positives, false negatives and false positives. Okay, so to create a confusion matrix, you can use just a confusion matrix, as we have imported the confusion matrix one here. So you can just pass on this function where it is gone, like the confusion matrix. Okay, you can write this the confusion matrix, then you can say you want a confusion matrix of one, sorry, y comma the model dot predict of x. So you'll get some array over there that states that 3, 1, 0 and 6. Okay. Now try to understand what it's saying. So it is saying that 3 true negative predictions are there. 3 negative, 3 you can say true negative predictions. Again, I'm just bringing these things here. Let's bring this so that you can understand it. Okay, let's cut out this plot. Don't require actually. Okay. So see, mhm. Okay, you're having some three zeros here. Okay, actual was it was 4 and you are getting 3. Okay, so try to understand. It is saying that the first three observation are the 0, right? And these are predicted correctly. The first three are predicted correctly. Okay, that is you are having 3 as the true negative predictions, right? Okay, and then you are getting some 0 here. Like 0 is said to be false negative prediction, so it is no false predictions. Okay, no, like these are the ones wrongly predicted, right? So any one is wrong predicted? No, everyone is correctly predicted over there, that okay, these are the ones. Okay, one extra is also there, right? So these are the 0. Understood? What are these ones? Why these ones are there? So it is one false positive prediction, right? Positive stands for the 0, right? One false positive prediction. So always positive is 0 and the negative is like 1. You can consider in the confusion matrix. Okay. So this is one false positive, because you are getting some one value here, like this is one value only in the place of the 0. You have one particular false prediction over there, right? And you are having in the 6, this is 6. So this is 6 true prediction in the, you can say 6 true positive predictions. Okay, so these are the last 6 observation are once predicted correctly. Okay, so this is like a confusion matrix stage. Any confusions to you in the confusion matrix? When I was learning, I was having a huge confusion there. Even having confusion in the confusion matrix, because we will be plotting those things. Okay, then you will get a much good understanding with that. So, in confusion matrix, the 3 is nothing but the correctly predicted values of the starting 3. The 6 is the last 6 predicted correct values. This 1 is one wrong predicted values, and this 0 is like in the 0 and 1 there is no wrong prediction. Okay, okay, but in the 0 case there is one wrong prediction. Try to understand it like this. You are having total four zeros, and out of which you have predicted 3 correct, 1 wrong. You are having total 6 ones, and you have predicted total 6 correctly. That's it. Any I can say confusion to you guys? I think not should be there. Fine, cool, let's go ahead. So we'll plot this actually. Okay, we will just plot this and we'll see how it looks. Okay, so I have done this just in the data science ones. Well, we'll bring from there. Oh, it's a day ago. It's T15, I think. Well, yeah, Seaborn. No, where is do it? Okay. Cool. So this is not of your use. Was it? Yeah. Now we'll just plot these things. Okay, we'll have to make small changes. Confusion matrix, CM confusion. Okay, we have imported, so we're not going to write this. So figure and axis plot. Let's make it 8 cross 8, and I am show CM. CMap is given. Let's make some grid and have to be false. X-axis takes 0, 1, labels correctly, predicted 0, predicted 1s, y-axis set and find minus 0.5 and range of 2 text and center. Okay, cool. So let's run this. Predictions is not defined. Yeah. Mm-hmm. So you can go with the predict of x model dot predict of x. Cool. Whole. It's great. It's quite big. Okay. So as you can see here, if you can see, it's white. Let's make it black. Let's make it red. That is visible to everyone. Fine. So see, this is particularly a confusion matrix you are getting, right? That is exactly 3106. That is 3 1, and if I make it black, you could see it more clearly. So this is 3 1 and 06. That is actual zeros were 4, out of which you predicted correct zeros as 3. Okay, actual were 4. You predicted 3 correct, and you predicted ones correctly as 6. So predicted zeros correctly is 3. In the ones is 6. Okay, actual zeros were 4 and the actual ones were 6. So this was a correct predictions. Okay, that is just a confusion matrix study. Okay, I hope this would be clear to you. Fine. Next, you can go up and just go with the, you can say, the classification report, right? So if we just write the classification report, and the classification report of let's say y and the model of x. Okay, there you have to write predict. So classification report of this is like you're getting the F1 score, as I said, like how we do the precision, the recall F1 score, the support, the macro average, and all these things. Okay, so let's say I want only the accuracy to find out. So what is the accuracy score? So accuracy score of this, you can just write like the accuracy score of any x or like that. Okay, so accuracy score of x, oh, y, or the predicted one you can take. Accuracy score is like okay, cool. I can see one positional y. Okay, y. So y predictions is not there actually. So how will we go with that? Let's take it with the model and compare it with the x, and then I think it will be there. Yeah. So, oh, so 90% of accuracy score, as like here also you got, right? So a model is predicting 90%. If you want to improve it, you can also improve it. Like you can give some more changes to it. You can give some changes here, and you can like improve this if you want. So how you can improve actually? Like if you see the graph, guys. If I just say that I want to see the graph, sigmoid graph actually. So if you just plot this, Uh, Data must be one dimension. Cool. So you can see a graph, right? That is like starting from 0, and some values are here, and then it is just going straight away to the uh, your, you can say, as the one spot. Okay, you can even get a scatter of that. So see, the 6 values are there in the one spot, and the rest of there are the 0 part, right? That is, so let's say what is not taking there. Oh, this input output passing errors. One dimensional data must be one dimension. Very good. This is one. Oh, okay. Let's say this is S, and so what is there in the X actually? 0 to 9, right? So see, like a graph. Hmm? Like 4 sections here in the one, and the rest of there in the above, right? That is like just a logistic. Actually, this is a kind of how logistic work. And now if you try to pass a linear regression model in this, right, when you want to like give a line there, so what do you say, if you pass a linear regression, will it take all the points? No, a linear regression graph could just go from here a straight line, and that will go like this, straight like this. And what about these points, how these points, these are actually so far from this, right? They cannot come actually there, right? So these are things. And even if you want to just improve your graph or improve your model, so you can improve it. So what you have to do is you have to make some changes. How? Let's say this is model, right? Again, we are going to do all those things what we have done. Logistic regression, the same solver. The C value will give now to be 10.0, and the random state as 0. And we'll just fit our model to the X and Y. Done. So like these are the intercept and the coefficient. Okay, that's nice. So model dot predict probabilities of the X, and that is looking nice. Fine. So let's say these are our predictions, which is model dot predict and that of X. Fine. So let's see the confusion matrix of this y and the predictions. So that is nice. No errors are there. 4 exactly correct zeros and 6 exactly. So that is like very easy. If you have a small data, there you can exactly get 100% accuracy. But when you work with the real time data, it's very difficult to get, because in the real time these are your data, you have feed this data and you have made out, right? But when you go with the real world implementation, there are a lot of people with some different thinkings, and like they will create their own data. They will write also, like just take an example, right? Just take an example, like we are having a workshop like in the IIT Bombay, right? Now let's see this how this data works, right? Let's say 1,000 students has registered from there, but you see like in the semester or year, someone has written third, some has written 1 by 3 second, or the 1 by 3, and see like your data could be anything, right? And then you have to change on all these things. Confusion matrix, what will happen if you give model or predict comma y? Well, the confusion matrix, sir, in confusion matrix, what will happen if we give model dot predict comma y? Will the matrix now change? You want to go with this? Model dot predict and model dot predict and the y. So predict of x and the y. So that will be remain. No change will be there. Why? Because your x has been regenerated, and when you predict this, that will be the same as this, because predict is nothing but model dot x. So that is predict and the y. Okay, understood? Mm. Okay, sir. Yes, sir. Fine, good. So like this is your model now, and like if you pass on the if you pass on this now, let's say this to be here, and this is predictions, and oranges in case of this used, mm, greens, fine, looking good. So nice, right? All the values are fine, 4 correct, and there is no such errors, everything is good. That is how you actually predict some things and make out from this. Okay, you can even get a, like if you want, you can even get the your mm, what do you say, the graph. Okay, so model score, model predictions, classification report, and all those things, right? If you see your model score now, what do you see, what you will find? Model dot score of x multiplied by 100. 100% accuracy, right? So that are the cases how you can go and deal with the things out there. Okay, so there are a lot of process of how you can make models. Again, you can get a lot of things. Okay, so let's take another example. Okay, again we'll take some things, and again we'll do some objects there. Okay, so stats model is there. Okay, some stats model API is there. One more you can say package, like if we take like another process, if I say, okay, so we'll quickly import this stats model dot API. Okay, this is actually models. Yes, SM. Any errors? Mm. So you can get inputs and outputs in the same way like we did in the scikit-learn. Okay, you don't have to do any changes like on. Okay, so let's say this is an range of 10, and then the reshape of -1. Oh, shit. This is -1 to 1. and y to be an array of 0 0 and some arrays, let's say we change 1 0 0 1. It's 1 2 3 4 5 6 7 8 9 10. Cool. And then let's say x equals sm dot add constant x, right? So add constant takes the array x as the argument and returns a new array with the additional column of ones. Okay, with an additional column of ones. Now if you look on your x and y, you'll see how your x and y looks like. So this is your x with an additional column of ones will be given there, right? What is your y? This is your y. Fine. So like the first column x corresponds to the intercept and the second column take the original value of x. Okay, fine. Now again we'll create a model and then we'll train this. So let this model is equals to sm dot. Now this is logic we'll be using now x. So like the first argument, no attribute of logic. Oh sorry, it's L capital. So like when you create this model in the scikit-learn, you use fit there, right? Right? You use fit in the existing data, right? So here, like with the stats, we have to use L1 regularization, that is with the logit functions. Okay. So if you see your result, result. So result will be the fit, and let's say the method we are using is Newton. Optimization terminated successfully and current function. Okay, fine. So your model is now ready and the variable results will be having some things. Okay, so let's say this is results dot balance. We are getting there. So the first element obtained by the array is the intercept and the second one is the slope you are getting. Okay, this is a quick method of getting things. Okay, so now we'll evaluate a model. So that is nothing but result dot predict of x. So these are your predictions. Okay, and now do one thing. Let's say we result dot predict of x, and let's take it to be 0.5. We'll change the type to integer. It's in float. So if we change on the integer, what we'll see our values to be 0 0 0 and all these ones, right? So the obtained array credit what you got is the predicted output. Okay, as you can see like in the here. So you have 1 2 3 and something like that, right? So you need to see the table of the confusion matrix. So here, like if we use stats API, so we'll have to go with the table in place of the confusion matrix. Okay, like that we'll use result dot the prediction table. Okay, so 2161 is the ratio. Fine. Out of 3, 2 is correct, 1 is wrong, and out of 7, 6 are correct, 1 is wrong. That's nice. Okay. Now you can use summary or summary to get output also. Like if you write as result dot summary. So like you will get like model, what you use, method you used, the date, the time, the conversion, and all those things are written out there, right? The coefficient, standard errors, x1, and like number of observations we took out. Set. Okay. Similarly with that too, if I use results dot summary 2, so like things you have two methods to get out with that, right? So that is like very similar to use these things. Okay, now I think that would be helpful for you guys if you go with that. Okay, fine. So we'll quickly make a one, you can say, model on the tightening dataset, and then we'll give you some of the examples of what you can do with these models, what you can do with these techniques to work on that. Okay, so we'll start this iris one. We have started, right? This iris dataset we started, but we didn't go through it. Okay, so first let's go with the iris dataset. I hope this will be clear to you, right? Okay, linear was very simple actually. Logistic is very complicated there. Fine. That's why we say linear to be a very simple one to work. Okay, fine. Okay. So, like we have load our data and everything is fine now. So, once just bring this info, iris is not defined. I think it's VF. Fine, it's VF. And you have a lot of things over there, right? So, we are not going to just get one by one things over there. Okay. So what we'll do, we'll quickly see a LM plot of the regression line. Like if I say that this is figure, LM plot got an argument of color. Nice. CMap also not works. Fine. Let's remove this. Okay, you just get a thing out there. So this is your just one regression line you can say on, like a common one. So let's make it as on the basis of the species. Fine. So what you see is a petal length versus the sepal length, and this is a graph. Similarly, you can go for each of one, like the petal length versus the sepal width. And the sepal length versus the, okay, I think petal and sepal has been done. Petal length and sepal width. Petal length and petal width should be also there. Petal length GTH and petal width. So like you can see the graphs out there, and in every graph you can see if we go for a clustering also. So this will be the setos as the basic clusters type. Fine. Okay. I have said that I have made all these clusters projects and all for you guys. You can go with that. Okay. We'll be training it on the basis of this four columns, like your features. What should be your features actually? So what should be your features? If I say the features in that, so your features should be the like these all. Like let me just write again. Df dot columns to list. So if you see, what are your features actually? These four will be your features on the basis of which you will be predicting your species. Correct. So let's just start this. You are making an iris model. So let's say this is iris, and you pass this logistic regression there, and you can write your random state and all those things if you want to make it there. You can write that too. Okay. So it is not necessary. It's an optional process. If you want there to write itself, you can write. If you don't want, don't write that, because that will actually affect the outcome. So let me just write it there, and then we'll see how the outcome comes. Okay. So you can say here itself that random test, or let's say let it be as this. Okay, we'll split it first. So logistic regression, we are going to pass this. Okay, and that passed, I think that is done. Logistic regression. Yeah. Now let's say, okay, uh, let's just make x and y first. So let's say we are making some x and y. Now my x would be df of all these things, right? Because on the basis of this, I'll be taking, right? These are my features actually. So their values are my features, or you can say these are my features, right? And similarly, this is your outcome. Simple length is not possible. Okay, so if you see your x, this is only the 4 columns. What is your y? This is the series. Fine, cool. Now this was a part of, like, you have selected your datas. Now, now we'll try to split our data, like in the X train, and we'll make some training data sets and testing data sets. Y train, Y test. As I said yesterday, right? Remember the training things and all those. So one more thing you have to write before writing this. So this will actually split out your training and testing data set according to your features. So let's say you want test size as 0.33%, and you say random state to be 1, right? Let's just cut this and this right from sklearn dot the model selection, import this train test split. Okay, that is necessary to write this, because after this will work. Train split is not okay. TRAIN. So split it out. If you see your train dot head, sorry. So this will be like some data, like that is only 1, 2, 3, 4, like that much data. Okay, you can see the reorders has been done, right? The orders has been like you can see the index values has been changed, right? Similarly, if you see your test, that is again with some of the things, right? Now, what is this Y test? What does this Y test contains? This Y train. Okay, so this is the data you are having now. Okay, so if you just see on the total length of the things you are having, that is the length of, we can say, because we are having no null values, right? So length of this df of index is 150. So you are having 150 elements. Okay, and what is the length of this X train data? that is 100. So you are training your data with 100 things, and what is the length of your, obviously, the X test data? 50. Okay, so 50 is your testing data, and 100 is your training data. Understood? So you have splitted your training data set and the testing data set, and now you are going to make a model with those things, right? That's fine. Now you say this is your iris model. Pass this logistic regression there. Fine. And then iris dot fit the data to this X train and this Y train. So that is also done, right? And just that's over. Now you get to your predictions. Your predictions would be iris dot predict and go with the X test. So X train. So now I'm not going with that. Okay, so you have seen with all these things. Just go and find the classification report of this Y and the predictions. Found input variables of consistent numbers of samples, 150 and 50. Okay. Okay. So let's take it the Y test. Fine. So you got something over here. Okay. So we want the score of this. We want actually the score. So iris dot the score of this X and Y multiplied by 100. 98% accuracy. That's very good. Okay. So you have got like your model is trained with 98% accurate values, right? So what are your coefficient? These are your coefficient. And what is the intercept? If you write iris dot predict, so it is predicting that this is a Virginica species. Okay. So like this, you can see the predictions over there. Okay. Fine. Understood. You can make on predictions more over and like that. Okay. Fine. So like that, on the basis of these things, you can make projects and all this. Okay. Now we'll go to see this Titanic data set also, so that you can get a clear conceptions. Okay. As we have to sum up today. So like it's the last class today. So now we'll go with the Titanic. Now your test will be okay. Fine. So let's say load the data. I'm taking the data as Titanic, and let's say to be T. That's load data set T. Right. Fine. So here till now whatever we have dealt with, okay, till now we haven't done with our syllabus. All right. Okay. So like what are the remaining part are there in your drive? Okay. So those are in your drive. Yeah. So what I'm saying that till now whatever we have done is like with the full values, right? There were no null values over there. Now let's say this is a data set which is having some null values also, right? There are some null values. So what to do with this? Like if you can go and some, like with the starting you can go with the drop NA of this, and also you can write in place true or whatever you want. So let's say T equals this. Now your values would be something changed, like you can see like 0, 1, 2, 3, 4, 1, 3, 6, and 9. So the data structures or like the finding part of the things, right? Or you can say uh, the values, or you can say our data wrangling or cleaning part. You know all those things, right? Because you have done, you spent like 3 to 4 days on the pandas, so that must be clear to you. Okay, we are not going in that much things. Okay, so I will just quickly make up things over here. Okay, so let's say I want to see the age of the person, like who survived, the, like you can say the histogram of the person who survived, like the in the total data set. What is the number of person, like, or what is the average age, you can say, those who survived, right? So what we can do is we can just say let's see this colon to be survived. Okay, and can map up with histogram. You can write our bins to be 20. Like bins is nothing but the you can say the intervals what you want, like 20 intervals, 40, 60, 80, or like in 30 of intervals, like that, right? So if you take it with the interval of 10, it would be something different. Let me show you. Survived as, I think, S is small. Okay, still errors. Index age, none of the index age in the columns. Okay, age, age, columns are survived is fine. Yeah. So you can see like the bins you are taking on. So that is how you are getting the things, right? If you take it as 20, that's the difference. Understood? All right. Now we'll go with the data wrangling part, that is like cleaning and all those. So cleaning we have done. If we just see the t dot is null and dot plus sum. So you'll see there is no null values over there. That's a nice one. Okay, that's a nice thing. So what you will do now, as I said, like in modeling, you will have to make models which would be like having a discrete value. So here we can see like a lot of non-discrete values are there. How we can train on this? So we'll have to make something discrete, right? You will have to make some discrete values from here. Okay. So what we'll do is we'll start making some values with this. Like we'll start making some dummies values on this. Okay. So let's take this 6 column, right? And let's write that we want some dummies of this t. You can say t of this. So if you see your head, so you'll see that there is some female and male distributed over there, right? That is, if it is 1, then if it is a female, and 0, that is not a male, right? Obviously. So if 0, 0 or 1, 1, we can just identify it. Okay, so if I just drop the first one, if I just say that if I drop the first, still I'll be able to see I'll be able to see that this is I'll be able to categorize that this is a male or this is a female, right? If it is 0, then this is obviously not a male, this is a female, right? So that is like for similar basis we'll be going to make the dummy values for this embark and the classes itself. Okay, so let's say this is embark and this is pd dot get embark is Similarly for the class, so let's say this is CL and PD dot get dummies of T of, I think it's P class, and let's take right. So after this process, we'll just concat of the things in this T itself. Okay, so we'll say this T is equals to concatenation of T, this embark column, the CL column, the X column, and all these things in the axis of 1. Okay, so if you see now T of head, you can find out that the graph, the data frame will have some discrete values over there. Fine, we can easily classify. So now we'll be removing the unwanted features, because we'll have to select. What we want to do is we want to predict the survival of a person on the basis of their features, right? So what we'll do, we'll remove this alone, alive, embarked, down, and all those things. Okay, so let's just take the T dot columns to list. Fine. So we want to remove this P class, this 6. Okay, this is made by us, or like no, the 6. This where it is? It might be there as male or female. Yeah, fine. Age, no, let it age be there. Okay, just write one by one. So we'll drop actually, and what is to be dropped, you have to write there. Like you want to drop this 6 column, you want to drop this embarked column. I'll be dropping this passenger. What are these things? Okay, so let's write one by one. So this is fare is, let it be there, embarked and embarked down. Also this Q, no, not Q, it's 2 3 alive, alone, deck, who, adult, male, class. I think that's enough. Let's see if anything is left over, because we want to give our data maximum approach, we can give it as a discrete. It's T dot drop. Embarked, embarked down, alive, not found in the axis. Embarked, embarked down, alive, done. So let's see the head of this. Now I think with these things we can just go class of the people. Class, we have defined the class also, so let's drop this to anything more? No. So we did 2. This is T, and we are having survived age, sibling, past, where the male, the cities from where they have embarked, and the classes and the gender, right? This is fine to work with the data. Now you will make your training data and testing data. Okay. So x would be t dot drop this survive, because this is actually we want to predict. So drop the survive, and after dropping, whatever left is the training data. Similarly, y would be no, not take it as this. This would be the survived. So see your x dot head. This is x, and this is y. Okay, the values over there. Fine. Now again, you go in the training testing part, write those things out there. So let's take it from here. This part. Copy this. So X train and X testing, all these things. Let's write these things up. Okay. Testing size is this. Training size is this. So let's make it a bit less. 30. Let's make train much more. So run this. Now you see your X train. So first let's find out what is the length of total uh, X now. What is the length of this X dot index? If you're having X, what is the length of that? So 182 data are with you to practice on, right? 182 data are there for this X, okay, this index. Out of which, if we say, what is the training data set? It's 127, fine. So that's the remaining is the testing data set, fine. So that is again nice. So let's say Titanic dot, or let's say first pass on this logistic regression there, passed on. So Titanic dot fit, and pass on the X train, and the Y train. So 1.0 and total number of iterations reasonable, fine. Now you did this thing, and just come up with the predictions on all those. Predictions would be the dot predict, fine. If you see your X train head, you'll find that this has been reshuffled in many ways, right? See, the orders have been typically changed out there, right? Okay. Now you can go with all these same process, like you can find out once you have made, you can just find out this score, the classification report, the coefficient, intercept, and the predict. Okay, so go with this all. So let's go with the classification. Report of this Y prediction. So you got a classification report over there. Okay. So what is the score? So if you find the score out there, that would be score of X and Y multiplied by 100. So your score is 76%. Cool, no issues. So like Titanic dot coefficient. Okay, and the intercept. Right, we can predict the things. So let's predict up how we have this written there, like the x, while writing the datas as we have written. That is, so let's say the age and all these. So age is 23.4. The siblings and spouses were not there. The parents and children were 1. The fee he has given, let's say it's around 45.76, and embarked from Queenstown, not from the Southampton, was not in the was in the second class, not in the third class, and was a male. Method object is not subscriptable. Okay. Reshape your data either using reshape minus one and a single reshape minus one. Oh, it's not predicting. Okay. Okay, confusion matrix will give us a good report. So let's say y test predictions. So total, okay, there are some wrong predictions too. So total 17 were the zeros, and you got 10, and in 28, 10 are wrong. Okay, fine. So you can get a scatter plotting of those things again, like the original values and the predicted values. So what will the original values? Yes, ns dot scatter. So original values were the p of survived, right? Versus the predictions. Okay, let me cut this. What are the predictions? These are the predictions, right? So the original value were, what are these, are from the y test, I think, x test. Okay. So some 50 values are there, first 50. So predictions, what is the length of predictions? 55. So like this, right? So you get a graph which is having just a value with the 0 and 1. Okay, so these are the things like how machine learning works exactly. Okay, and even for like the AI part, or let's say for the that logical part of fuzzy logic and all those things, there are programs. And like if you see, if I just make you see here, let me stop the recording.